No, Atharv, I'm not going to discuss the questions in this because this is not a doubt session. This is a cover-up lecture for students who of ICSE only. Okay, this is only for ICSE students. If you have attended all the lectures of vectors, then you don't need to attend this lecture. Okay, so I'm going to start with the revision of dot and cross products. So this is a revision lecture for ICSE students only. Okay, those who have missed the vectors lectures towards the end because of their preparation of ICSE, it is only for those students. Okay. If you have doubts which you want to discuss, then please log on in the evening lecture at 4 o'clock today. During that, okay, we have a doubt lecture from 4 to 6 today in the evening, and during that you can discuss your doubts. Okay. What syllabus are you talking about, Raj? Please specify what syllabus do you mean with syllabus question mark. So we will start with the revision of scalar product applications. Syllabus of test is entire vectors. Syllabus of the test students is entire vectors portion. Entire vectors and entire kinematics one which we studied in that second track. Okay, so coming back to your applications of dot product or scalar product. So first of all, we saw definition of dot product is EB cos theta, or in terms of component algebra, it is equal to AX BX plus EY BY plus AZ PZ. Okay, so hope these 2 points are clear to all of you. If anybody has a doubt in the basic definition of dot product, please let me know by message. Atharv, let me check. Just give me a moment. Let me check. Yes, that is correct. Your lecture today evening is this one. It is it's your biology revision lecture. It's not my revision lecture. So in that case, if you have any doubts pending, just drop me message by WhatsApp. Okay, I'll help you out with that. Okay, just drop me message by WhatsApp. I will help you out. Ritika, what is the difference between product of vectors A and B and AB? Okay. See, when you write, so Ritika, when you write AB like this is what we call just multiplication of magnitudes. Okay, this is multiplication of two scalar quantities, A and B. This is not any kind of vector operation. Okay, this is not any kind of vector operation. Whereas when we talk about scalar product, it applies to two vectors. See the difference over here. We are writing vector A dot product with vector B, and there we are just writing product of magnitudes. So this is a different thing. This is a different thing. Okay, you cannot compare the two. Is it clear, Ritika? So this particular symbol dot is used for scalar product of two vectors or dot product. Okay? Dot or scalar product. For this we use the symbol dot. Okay, and the definition is AB cos theta. That is magnitude of vector A into magnitude of vector B into cos theta. Or if it is in terms of the components, that it is AX BX plus AY BY plus AZ BZ. Is this point clear, Ritika? Okay. So now, for example, if we have two vectors defined like this, one vector A, let's say, has a magnitude of 10 units. One vector B, let's say, has a magnitude of 8 units. And the angle between them, suppose, is 37 degrees. Then what is A dot B? Okay. Just work this out quickly and tell me how much will be A dot B over here. Just apply the definition of A dot B and work out the value. Correct, Sanya? Samarth, correct. Yojit, correct. Tanish, correct. Shubham, correct. Shikhar, correct. Kanak, correct. Okay, so A dot B here will be AB cos theta. So you have to just substitute the values. Yes, Ritika, correct. It will be A's magnitude is 10, B's magnitude is 8, and the angle between them is 37. So 10 into 8 into 4 by 5. Cos 37 is 4 by 5. So this will become 8 into, sorry, not 80. So 80 multiplied by 4 by 5. So that will become 64. Okay. So 64 units squared, because there's a product of 10 and 8. Cos 53 is 3 by 5. Cos 37 is 4 by 5. We've discussed this many times. Cos 37 is 4 by 5. Sin 37 is 3 by 5. That's the same thing as cos 53, and that's the same thing as sin 53. Alright. Now similarly, if A plus B, suppose, is having a magnitude of 10 root 3 and magnitude of A is equal to magnitude of B is equal to 10, then find A dot B. How much will this be? Correct. That's good. So 50 is the correct answer. That's good. Okay. So you can see that because A plus B magnitude is 10 root 3. Yes, that's correct. 50 is the correct answer. Okay. So that means root of A square plus B square plus 2AB cos theta is equal to 10 root 3. So now substitute in this the values of magnitude of A and magnitude of B. So from that you will get the value of cos theta. So square root of 100 plus 100 plus 200 cos theta is equal to 10 root 3. Now you can square both sides. Okay. So 200 plus 200 cos theta will become 300. So from that you can see that cos theta is equal to half, or the angle between them is 60 degrees. Therefore A dot B, which is AB cos theta, becomes 10 into half. So 50 is the correct answer. Very good. Okay. Now, next thing we understand is application of dot products. So the first thing in the application of dot product, that is indirect application. When you want to directly find A dot B, that's also an application, but that's direct. Now, indirectly, when do we use dot product? So first is to check if two vectors are perpendicular, because since cos 90 degrees is equal to 0, therefore A dot B is equal to 0 if A and B are perpendicular. So this is a very important application, okay, that if you want to check if two vectors given in component form are perpendicular to each other, then the easiest method is to use their dot product. So for example, given a vector, let's say 2i cap plus j cap plus 3k cap, okay, which of these is perpendicular to E? Okay. So option A, suppose in this question, is given to us as vector B is equal to I cap minus j cap minus k cap. Then option B, suppose, is given as a vector B2, suppose, as minus I cap plus j cap plus k cap. And option C, suppose is given as B3 vector is I cap plus j cap minus j cap, and option B is given as B4 is equal to I cap plus 2j cap minus j cap. So you want to check that which one is perpendicular. So what you have to do in this question, yes, correct. Parikshit and Harshvardhan, that's correct answer. Okay. So you want to check this condition. This is what you have to check. Okay. So which one's dot product is giving you 0? That is what you have to check. So if you check here, A dot B1, for example, will become how much? Is product of X component, so that is 2 into 1, plus product of Y component, so that is 1 into minus 1, plus product of Z components, so that is 3 into minus 1. So that is 2 minus 1 minus 3. So that is minus 2. That means they are not perpendicular. Okay. They are not perpendicular. Then similarly you check A dot, yes, correct. This one. So again it is 2 into minus 1 plus 1 into 1 plus 3 into 1. So this time you can see this is plus 2. So again this is not perpendicular. Okay. Then option C you check A dot B3. Okay, so this one you can see is becoming perpendicular. It is 2 into 1. Okay. This one is dot product with this. So 2 into 1 plus 1 into 1 plus 3 into minus 1. So this is giving you 0. So that means yes, this is perpendicular to A. So this becomes the correct answer. Okay, understood. So this is the one of the very important applications of dot product. The condition for finding the perpendicular vector. All right, is this clear? Okay. Now next application of dot product is to find the angle between two given vectors. So this is also very simple, that since we know that A dot B is defined as AB cos theta, so just reverse this definition. So therefore cos theta is their dot product divided by product of their magnitudes. So you can say theta is cos inverse of A dot B divided by AB. So for example, I have a vector E which is suppose I cap plus j cap, and I have a vector B which is 2I cap minus 2k cap. Okay, now I say find the angle theta between vector A and B. Okay. So ये भी कैसे हो जाएगा? We'll just use this formula. Okay. So cos theta will be equal to A dot B divided by AB. Okay. So you can see what is A dot B over here. It is I plus j dot product with 2I minus 2k divided by magnitude of I plus j multiplied by magnitude of 2I minus 2k. No, it's not 90 बेटा. 90 होता तो 0 होता ना. अभी देखो क्या है dot product का? It is 2. The dot product is just 2. Because see A is I cap plus j cap. Okay, and B is 2I cap minus 2k cap. No? So A dot B is 1 into 2 plus 1 into 0 plus 0 into minus 2. Okay, so it is 2 only. That's why dot product is 2. Okay. But magnitude of A is root 2 and magnitude of B will become 2 root 2. So as you can see, this will become half. Okay. Yeah, all right, that's fine. But now you understood, huh? So cos theta is half. Okay. Or we can say that theta is cos inverse of half. Or that means theta is equal to 60 degrees or pi by 3. Okay. So this is the important application of how we use dot product to find the angle between two given vectors. So just note down this example and I'll give you more. So try this. Yes, Harshvardhan, that is correct. Vaishnavi, that's correct. Rahil, that's correct. So again, you can see that cos theta is equal to A dot B divided by AB. So यहाँ पे A dot B कितना हो जाएगा? It will be 2 root 3 plus 2 root 3, that's 4 root 3. And mod A is equal to 2 and mod B is equal to 4. Okay. So it is 4 root 3 divided by 8. So cos theta is equal to root 3 by 2. So theta becomes how much? It becomes 30 degrees. Okay. So this is another important application of dot product which you should understand. Okay, so people hope this is clear. Okay. Now we come to the third point, the most important application of dot product. Okay. So the third and final most important application of dot product. Okay. So to find the projection of a vector, okay, say E, along another vector, say B. Okay. So first of all, let us understand what this term means. Projection of one vector along another, or we sometimes say projection of one vector on another. Okay. Along ki jagah we might also say on. So the projection of vector A on vector B or along vector B. इसका मतलब क्या है? So let's understand what this means. So suppose these are two vectors A and B, and the angle between them is some theta. So if you drop a perpendicular from E onto B, then this component of A along the direction of B is called the projection of A on B. So if we write this as A parallel, okay, so this is the projection or you can say or component of the vector E along the vector E or parallel to vector. Okay. Whereas if you take a component in the perpendicular direction, so this direction is perpendicular to B. This is an axis perpendicular to B. This one becomes A perpendicular. So these are the two projections of A with respect to the vector B. So A perpendicular is the projection of vector E perpendicular to vector E. And A parallel is the projection of A parallel to the vector. Okay. So understood the meaning of these two. Okay. Now the next thing you can see is that the magnitude of the parallel component is how much? It is E cos theta. And the magnitude of the perpendicular component is how much? It is E sin theta. Okay. And also you can understand one thing, that vectorially the vector A is the sum of the parallel component plus the perpendicular component. But since the angle between the parallel and perpendicular component is 90 degrees, so in terms of magnitude, we will say that E is magnitude is square root of the parallel component square plus the perpendicular component square. So if you miss this part in the lectures, please make a note of this first. Yeah, perpendicular we can find from cross product, but there's no necessity for that. We can just find it from this dot product only. Sarvesh, component method is a method in which we do algebra using component representation of vectors. Something completely different to scalar product. So this method is the application of dot product, and component method is a general method of representation of vectors. यहाँ पे vectors already component form में represented है और हम उसपे dot product apply कर रहे हैं. So they're not comparable things. So we can't say what is the difference between them. But that is with respect to x-axis and y-axis. Here theta is the angle between vectors A and B. When you express the x component of vector A as A cos theta, theta is not the angle between vectors A and B. Theta is the angle of vector A with respect to the x-axis. Okay, so let us understand this with an example. Suppose we have this case now that the vector E is 2i cap plus j cap and the vector B is 2i cap minus 2j cap plus k cap. Okay. Now we say find the component, that is the magnitude of this component of vector E along vector B. And secondly, find the component in terms of magnitude only of A perpendicular to vector B. Then what we do here is see that the magnitude of the parallel component is E cos theta, where theta is the angle between A and B. Okay. Now E cos theta, mind you, can be written as E dot B divided by magnitude of B, because by definition A dot B क्या था? AB cos theta था. So E cos theta you just get by dividing E dot B divided by magnitude of B. Okay. So go back to this and see what is your E dot B. So E dot B is how much? It is in fact 4 minus 2 plus 0. And what about magnitude of B? It is square root of 4 plus 4 plus 1. Okay. So this becomes 2 divided by root of 9 or 2 by 3. Okay. So this is the component of A which is parallel to B. In magnitude form, this is the component which is parallel. Yeah, Nitish, I'll explain what I've written in the note part. Okay, so coming back to this thing over here, see what we've written down over here in the note part is the magnitude of the parallel component. Okay, that you can see from the diagram. This angle is theta and we have dropped a perpendicular. So what will this base be? It will be A cos theta. And what will this perpendicular line over here be? Or this, it will become A sin theta. Okay. So the vectors sum of the A parallel vector and the A perpendicular vector is nothing but the vector A itself. And just like Ax I cap plus Ay j cap used to be A when we saw two-dimensional component methods. But here we are not seeing along the x-axis. We are seeing along the vector B and perpendicular to the vector B. Okay, so along the vector B, we have this component, the parallel component. And perpendicular to vector B, we have this component which is the A perpendicular. So their vector sum, that is this plus this vector sum will become equal to how much? The vector E. And when we convert this vector equation into a scalar form, they are perpendicular vectors. Na? So what will be the magnitude of the sum of two perpendicular vectors? It's squares, it's square root of the sum of the squares. Okay. So this magnitude becomes root of E parallel squares magnitude plus E perpendicular magnitude square. Okay, understood. Okay. So that's what we are going to use in the question below now to find the perpendicular component. So parallel component आ गया ऐसे. So perpendicular component अभी कैसे निकालेंगे? So for perpendicular component we'll use the formula that E's magnitude is square root of E parallel square plus E perpendicular square. So we can say that E perpendicular will be square root of E square minus E parallel square. Okay. So now going back here, what was your magnitude of the vector E? So it's root 5. Okay. So E perpendicular will become square root of 5 minus understood them. E's magnitude is root 5. Okay, so E square is 5 and E parallel is 2 by 3. So E perpendicular becomes. Yeah, so see again what is happening. Your vector B is supposing this vector and your vector E is supposing this vector and the angle between them is some theta. So how we'll find the perpendicular and the parallel component? Drop a perpendicular from A onto B. So ये जो component हो जाएगा, this is the component of A which is parallel to B. और ये जो component हो जाएगा, this will be the component which is perpendicular. Understood now? So you can see that this component will just become E cos theta and this component will just become E sin theta. Now given A and B in component form, what is the easy way of finding E cos theta? E cos theta is nothing but E dot B divided by mod. And given now you know E cos theta, what is the easy way of finding E sin theta? It is square root of A square minus E cos theta the whole square. So that is how we have done the calculation here. We made use of these relationships. So make use of the dot product first to find the parallel component. So we made use of the dot product here to find that the parallel component is this much. Okay, and then make use of the property that this is nothing but A cos theta and this is nothing but A sin theta. Okay. So this is nothing but saying that A sin theta is square root of A square minus A cos theta. So A cos theta, this we had found out, this was 2 by 3 and A had a magnitude of root 5. We substitute that here. That is in vector form, Ritika. Here we are finding the magnitude. Okay, subtract A parallel from A to find the perpendicular one. That is in vector form. That is if we know A parallel in vector form, and then we want to find a perpendicular, that is going to be a minus a parallel. But here we are finding the magnitude. So इनमें magnitude में क्या relation है? Magnitude में ये relation है that yes, statistically you can use cross product, but generally we avoid using cross product because it's more lengthy. Okay. And in any case, the more important thing is the vector relation. So I'm coming to that. Okay, now next thing is yes, you can do that also, Shikhar. It's no problem. See, it's the same thing. The number of steps are same. आप cos theta निकालोगे, उससे theta calculate करोगे, फिर वहाँ से sin theta निकालोगे. So that's easier than that is just to use this relation, ना? That E perpendicular is square root of E square minus A parallel square. Okay, now the next thing, the projections E parallel and E perpendicular in vector form, that is not in magnitude but in vector form, in I cap j cap notation. So how to find this? So again notice that so when we drop this perpendicular here, ये जो projection vector मिल रहा है E parallel. Okay. Now this projection, it has a magnitude of E cos theta, and it has a direction along the vector B. Okay. So what do we denote the direction by? We denote it by unit vector. So E parallel as a vector will become its magnitude, which is E cos theta multiplied by B cap, where B cap is the unit vector along B. Okay. Or in other words, is the vector B divided by its own magnitude. Okay. So this is the method that we use to find the parallel component in unit vector notation. Okay, just make a note of this formula first. Then we'll see the perpendicular component also. mod of A is a short form used for saying magnitude of A. Okay. Mod is just as a word, we just use it as a short form for saying magnitude of A shape. एक ही चीज है, they're one and the same thing. Okay, now for the perpendicular component, we will just use the fact that these two, their vector sum, okay, is how much? It is a vector E. So since the vector E itself is the sum of the parallel component plus the perpendicular component, so therefore we can just find out the perpendicular component of E by subtracting the parallel component. So once you found this, substitute this here, and that will give you the value of the perpendicular component. Okay, understood the steps? Okay, so let's do one question from directly from your module as an example of this. So in parallel, there will be no difference between A cos theta and A cos theta B cap. No, there is a difference between. One is expressed in component form, the other is expressed as a magnitude. Okay, so there's a difference between the two. You will understand with the question. So I will start with question 21 of exercise 1, because that's a proper numerical problem. So for example, this one, question 21 of exercise 1. So in this, what is happening is vector E is given to us as I cap plus 2j cap plus 2k cap. And B is given to us as two I cap plus j cap plus 2k cap. We have to find the projection of vector B on vector E in vector form, not in magnitude form, but in vector form. So basically that means that suppose now this time, suppose this is vector E and this one is vector B. This angle is theta. Now we have to find this projection. To find the component of B which is parallel to E. And we will also add one more thing to this question. We will find the perpendicular component also. So basically, by this projection of B on A, what they mean is we want to find B parallel but in vector form. It's not the magnitude of this, but it's this. Okay. So same method now. So we'll start by understanding that B parallel has a magnitude of B cos theta, and B parallel's direction is along the vector E. So we have to find A cap. The unit vector will be A cap. So let's start by finding this. So therefore, B parallel's magnitude, which is B cos theta, इसको कैसे निकालेंगे? E dot B divided by magnitude of B. Okay. Now you know that definition of E dot B is EB cos theta. So therefore, what is B cos theta now? It is E dot B divided by mod. So use these two vectors now to find the dot product. So A dot B is how much? It is 2 plus 2 plus 4. So that's 8. And mod A is how much? It is square root of 1 square plus 2 square plus 2 square. Okay. So this is how much? This is 8 by 3. So B cos theta is coming out to be how much? B cos theta is coming out to be 8 by 3. Now the next thing is we have to also find out what this is, so that we can find out the parallel component as a vector. Yeah, Vaishnavi, I'll explain how to get the unit vector. Okay. We'll get it by subtracting the two vectors. Na? So directly as a vector aa jayega. Yeah, Sania, your answer is correct. Good. Okay. Yes, Rahil, correct. Okay. So now you can see. So therefore, and A cap is basically what? Vector A divided by its own magnitude. So vector A was how much? Vector A was I plus 2j plus 2k. So I plus 2j plus 2k divided by its own magnitude, which we already found out is 3. But anyway, let's write it like this. That is I plus 2j plus 2k, whole thing divided by 3. So this is A cap. Okay. So therefore, what will be B parallel expressed in component form? It is B cos theta, जो कि उसका magnitude है, into A cap, जो कि उसका unit vector है, because its direction is along. So B parallel we just saw was 8 by 3, and the unit vector was I cap plus 2j cap plus 2k cap divided by 3. So we can just take 1 by 3 outside over here and write this as 8 by 9 into I cap plus 2j cap plus, or we can also write this as 8 by 9 I cap plus 16 by 9 j cap plus 16 by 9. It's one and the same. However we write it, doesn't matter. So this is the parallel component. So this was what this question was actually in the module. But we will add that part. We'll also find the perpendicular component. तो perpendicular component कैसे निकालेंगे? अब ये vector B parallel आ गया अपने पास. So we have to just subtract this from which vector? The original vector B. We just subtract this parallel component B, and that will give us a perpendicular component. Okay, so hope this is clear. Now, to find the perpendicular component, since the vector B is the sum of the parallel component plus, okay, therefore that's it. So the vector B was, I think 2i plus j plus k, right? 2i plus j plus 2k. And the parallel component we just saw was this. So this will become 2 minus 8 by 9 I cap plus 1 minus 16 by 9 j cap plus 2 minus 16 by 9 j cap. So this will become 10 by 9 I cap. Okay, this will become minus 7 by 9 j cap, and this will become 2 by 9. Okay, so we can write this as 10 I cap minus 7 j cap plus 2 k cap, the whole thing divided by 9 also. Okay, so whichever we write it as, it's fine. So D perpendicular becomes this vector. Okay. So this is a very important concept. The projection of vector parallel to another vector, or the projection of one vector perpendicular to another vector. How we calculate these? Okay. So just make a note of this and try out one more question. My next example. Okay, so just try out this next example. Finish writing this down and try out this next example. Okay, so got the answer, people? Yes, very good. Yes, that's correct. Perpendicular component will be k cap and the parallel component will be I cap plus j cap. So this is very easy. Okay. So you can see that B's parallel component is B cos theta into A cap. So B cos theta is A dot B divided by mod A, and A dot B is 2 plus 2, and mod A is 2 root 2. So it is 1 by 2. So it's root 2. Okay. And A cap is vector A divided by its own magnitude. So it is 2i plus 2j divided by. So therefore, the parallel component of B becomes I cap plus j cap, and therefore the perpendicular component just becomes this. Yes, the answer is correct, Sarvesh. Okay, so this is the about the projections. Now the last thing in vectors after this was the cross product concept, or also called the vector product of two vectors. So as you know, the cross product or the vector product is given by this symbol, right? And by definition, this becomes equal to AB cos theta, AB sin theta, but into a unit vector. So it is AB sin theta into n cap. Okay. So E cross P is a vector quantity, unlike scalar product, which was a scalar quantity, such that the magnitude of A cross B is AB sin theta. And this magnitude is in fact equal to area of the parallelogram with adjacent sides E and B. Okay. If you draw a parallelogram where the vector E and B are the adjacent sides, I'll tell you what n cap is. You draw a parallelogram like this, then we can see that this being theta, the height of this parallelogram is B sin theta. and the base is E. So area is base into height. So that is EB sin theta. So that concept comes in over here. That mod of A cross B. Okay. So it is a vector quantity such that its magnitude is this much and the direction of A cross B is along n cap, which is a unit vector perpendicular to the plane of vectors A and B. So it's perpendicular to the plane of vectors A and B. Okay. So this is the definition of the cross product. So this here is the definition of cross product of two vectors. Yeah, I'll tell you someone. We'll discuss. So the area is the magnitude of A cross B beta. It is mod A cross B. And n cap is the unit vector which is perpendicular to the plane of A and B. No, it can be perpendicular to both, na beta. This is z axis is perpendicular to both x and y, na. So like that, n cap is perpendicular to both A and B. So that's why it's perpendicular to the plane of A and B. Okay, now let me complete this part. Okay. Triangle inequality is something we discussed a long time ago in the sum of two vectors. It will be there in the session recording of session 3, 4, etc. of vectors. Triangle inequality is very simple. It just states that the sum of two vectors cannot have a magnitude larger than the magnitude of the sums. Okay. So if one vector has a magnitude of 5 and another vector has a magnitude of 10, then mod of A plus B cannot be larger than 15. That is the triangle inequalities part. Yeah, I'm coming to it, Shikhar. Okay. So have you written down this part? Lies perpendicular to the plane of A and B. Yeah? So this statement here means that it lies so let us understand, okay, further about n cap. The direction of n cap is determined by what we call the right hand palm rule. Okay. So basically you can understand one thing, that suppose vector A and B are like this. Suppose this is vector E, this is vector B, and the angle between them is theta. Okay. So n cap is the unit vector perpendicular to the plane of A and B, but given by right hand palm rule. Now see, tell me, if I just use this much, that it is perpendicular to the plane of A and B, then in this diagram, where can n cap be? A and B are lying where? They are lying in the plane of the screen. So what is the direction of n cap? What is the direction perpendicular? It's either coming out or going in. You understand me? See, A and B are lying in the plane of your screen. So what is the direction which is perpendicular to that plane? It is either coming out, yeah, like k cap, or going in like minus k cap. Okay. So how do we decide which one it is? So to decide whether it is coming out or going in, we use the right hand palm rule. So what is the right hand palm rule? Let's understand the steps of the right hand palm rule. So the right hand palm rule is such that place your right hand such that the thumb is pointed along the vector E, okay, and the four fingers are along B. Okay. Then N cap is along the direction where the palm faces. Okay. So basically, if this is the vector E and this is the vector B, now, so to calculate E cross B, what we'll do is we'll place our right hand palm on the surface of the screen. We'll place our right hand palm on the surface of the screen such that our right hand thumb is pointing along E. This is where the thumb is pointing. And our right hand fingers will point along the direction of B. So now where our palm is facing, when you place your hand like this on the screen, you are seeing the palm. That means the palm is facing towards us. So palm faces out of the screen. So that means N cap का direction क्या हो गया? It is coming out of the plane. It is coming out perpendicular to the surface. So this is an example of how we use right hand palm. Is it clear to all of you how we got the direction of N cap as coming out and not going in? No, coming out means positive because coming out means anti-clockwise. Anti-clockwise is taken as positive. Now similarly, just see what is happening in this example. Suppose E is like this and B is like this. Now find the direction of A cross B. Coming out or going in. Yes, very good. It is perpendicularly going into. So just use this principle over here. Yes, correct. It will be going into the plane here. So यहाँ पे we'll have to place our palm in such a way that your thumb is pointing along this direction and your fingers are pointing like this. So when you do that, you see your knuckles will be facing towards you. Your palm is facing the other way. You're placing your hand like this. So you see your your knuckles are facing towards you. Your palm is facing the other way. So this is palm faces into. Okay. That means A cross B is into the. Okay. So now, for example, if we have a question where in the xy plane, I have drawn vector E like this. It's of magnitude 20 and at 30 degrees. And I have drawn vector B like this. And this is of magnitude 15. Okay. So we have to find out A cross B. Over here. Find out the value of A cross B. Work this out quickly. Yeah, we are doing cross products here. So you can see that A cross B will be equal to AB sine theta n cap. Now what will be theta over here? Theta will be this angle. So you can see that here magnitude of A is 20, magnitude of B is 15, but theta is how much? It is 120 degrees. Okay. So sine theta. Okay. And similarly, what about n cap? Now n cap here will be coming out. So coming out will be what? It will be k cap because z axis is coming out of the plane. So understood now why it is coming out, because you place your thumb like this and your right hand fingers like this. Your palm is facing outwards. Okay, so facing outward is positive z axis. Okay. It's coming out of the plane, so it will be plus k. So magnitude of A cross B, which is AB sine theta, will become 20 into 15 into sine 120. So that is 20 into 15 into root 3 by 2, or 150 root 3. Okay. And n cap is nothing but positive of k cap. So therefore, A cross B becoming 150 root 3 k cap. This should be our final answer. Yeah, because by right hand palm rule, I have shown that the direction of A cross B is coming out of the plane. Place your right hand thumb along A and your fingers along B. Your palm is facing towards you. Yes, the right hand palm rule is used to define whether the unit vector is coming out of the plane or going into the plane. So in this case, coming out of the plane is which direction? It's the z axis. Going into the plane is what? The negative z axis. Okay, so it becomes like this. Is it clear, people? Ritika's second quadrant sign is positive, beta. ESTC, no? Okay. Yes, you can get something like that. So I'm coming to that. Okay. So now we will look at the cross product in I cap, J cap, K cap terms. So here it is very important to understand that I cap cross I cap is how much? 0. Because any vector cross product with itself is 0, because it is a square sine 0 is 0. Okay. So J cross J is 0 and K cap cross K cap is 0. But I cap cross J cap is positive of K cap. Now how we can understand this? See, I cap is 3-dimensional. If you think I cap is a unit vector which is perpendicular to J cap. And both have magnitude 1 each. So what about K cap here? K cap is the direction like this. So here you can see that if you do I cross J, okay, it will be 1 into sine 90. But what about the direction? The direction will be the direction of I cross J. So that is pointing in the direction of Z axis. So that is why it is nothing but theta. But similarly, if you do J cross I, that becomes minus. Just work it out over here. Yes. Place your thumb along the y-axis and your fingers along your x-axis. You'll see your palm is pointing into the plane. So that is minus k. Now similarly, if you see J cross k will become I cap. Just write out here. Point your thumb along the y-axis and your fingers along the positive z-axis. So you see your palm will point along the positive x-axis. And likewise, k cap cross j cap will become minus I cap. So for this also you can try it out. Point your thumb along your z-axis and your fingers along the y-axis. So see your palm will be pointing along the negative x-axis. Is this clear, Beta? And similarly, you take K cross I. Okay. Yes, that's correct. Okay, Shikhar. If you take K cross I, point your thumb along your z-axis and your fingers along your x-axis. So your palm will be pointing upwards towards the positive y-axis. So that will be j cap. So likewise, I cross K will become minus j. Okay, so that is why if we have something like this, so hope these expressions are clear to all of you. So for example, if we have something like this, that the vector E is suppose 3i cap and the vector B is 2j cap plus k cap, and we want to calculate A cross B, we can just write it as 3i cap cross product with 2j cap plus k cap. Okay. Then open this bracket using what is called distributive property. So 3i cap cross 2j cap plus of 3i cap cross k cap. Okay. Further, that becomes 6i cross j plus 3 times I cross k. Now just make use of these formulae here. You can see that I cross j is nothing but k, and I cross k is nothing but minus j. So you can see that A cross B here will become this vector minus 3j cap plus 6j cap. Now you can check that this one is perpendicular to both A and B. If you take dot product with A, you can see it's 0. If you take dot product with B also, you can see it's 0. Okay. This last step, so I cross J को मैंने कहाँ से substitute किया from this set of formula. So here I cross J is substituted from here, this formula, it's plus K cap. Whereas I cross K is coming from this last formula here. I cross K is minus J. Now how we can check that this A cross B is perpendicular to both A and B? Take the dot product. Take the dot product of this one with A. You can see it's 0. So it's perpendicular to A. Take the dot product of this one with B. You can see again it's 0. Okay. So but this is about cross product, no? It's not about dot product. Okay. Now here you could see that because A had only one component, the x component, no y and z. So it was easy to apply these steps. But in case A has all three, Ax, Ay, and Az, and B also has all three, Bx, By, and Bz, this becomes a very complicated process because you will have three components here, cross product with three components. So it will become 9 terms. So for that, we have a shortcut method of calculating A cross B. So if we have the general formula that A is Ax I cap plus Ay j cap plus Az k cap, and B is, yeah, it is perpendicular. Samarth, I showed you it's perpendicular. The dot product with both A and B was 0. In that last question, if you calculate the dot product of the cross vector A cross B with respect to A, it's 0. If you calculate the dot product with respect to B also, it's 0. So hence prove that it's perpendicular to both A and B. Okay. Now for calculating A cross B here, we have a shortcut formula which makes use of determinant of matrix. So we write a 3 by 3 matrix. Okay. So the first row becomes the unit vectors. The second row becomes the components of the vector E. So it is Ax, Ay, Az. The third row becomes the components of the vector B. So Bx, By, and then we calculate this in the normal way. Like we calculate the determinant of the matrix. So this becomes I cap into this 2 by 2 matrix, Ay, Az, By, Bz, okay, minus of the middle term j cap into the matrix formed by the first and third column. So Ax, Az, Bx, Bz plus k cap formed by into the matrix formed by the first and second row, because you've taken the third term, so the first and second row will come here. So Ax, Ay, Bx, By, and the final step, you solve each of these 2 by 2 matrices by first diagonal minus second diagonal. So this becomes Ay, Bz minus, that is the rule for the determinant. The middle term comes with a minus sign. Determinant of matrix you have studied in solving of simultaneous equations, so you are aware of it. Okay. It's that same principle here also. Okay. So this is how we get the final value of the cross product vector. So A cross B comes like this. Okay, so if you haven't seen determinant of matrix in 9-10, then just note down this formula. We'll do a bit of practice and you'll understand how to do it. But I think determinant of matrix is definitely part of ICSE maths. Okay, so let's understand this with an example. So you don't need to memorize this formula actually. You need to understand how to solve this determinant. That's all. Okay. That's the easy thing over here. So for example, if we have the vector E as I cap minus j cap plus k cap, and I have the vector B as 2I cap plus k cap. And I ask you find A cross B, okay, and find magnitude of A cross B. Okay. So I will just use this determinant method. So A cross B is given in 3-dimensional form IJK. So I'll write a 3 by 3 matrix first step. So matrix का first row क्या होगा? It is IJ. Okay. Second row क्या होगा? A के components. So they are 1, -1 and 1. और third row क्या होगा? B के components. So they are 2, 0, 1. Notice the y component of B is 0. So the middle term here will be 0. The z component is 1. So the last term will be 1. Okay. So now I have to solve this determinant. Okay. So what we'll do next is we'll break this up. So you take I cap outside. So you're left with which two columns? These two columns. So -1, 1, 0, 1. Then when you take j cap outside, remember there will be an extra minus sign because it's the middle term. So now remove the middle column. So the first and the last column, you're left with what? 1, 1, 2, 1. And similarly, now take out the k cap term but with a positive sign. So k cap is the last column. So remove it out. So you're left with the first two columns. So 1, -1, 2, 0. Okay. So now this term becomes what? This diagonal minus this diagonal. So it's -1. So this is minus I cap. Okay. Minus this one becomes how much? 1, -2. So that is -1 j cap. So this will become plus j cap actually, because the determinant of this is 1, -2 or -1. Okay. And plus the determinant of this one is 0 minus of minus. So that's plus 2. Okay. So the cross product finally becomes minus I cap plus j cap plus 2k cap. So this is our A cross B in IJK form. And therefore you can see its magnitude is equal to square root of 1 plus 1 plus 4. So that is root 6. You have to subtract inside C any determinant of this type now. This becomes A1 B2 minus A2 B1. So that's how we are getting these terms. Understood, Sarvesh? That is the rule of the determinant. The middle term comes with a minus sign. Newton's laws will start in the next lecture, Sarvesh. Shikhar, what do you mean 5 terms? Acha, you mean 4 by 4 matrix and 5 by 5 matrix? Yeah. Even terms will come with negative sign. Odd terms will come with positive sign. Okay. But here we don't really use 4 and 5 dimension matrices. Okay. In vector algebra, we have to use up to 3. No, Tanish, here it will be a 3 by 3 no? Because we are using it in vector algebra. So try out one question. Okay, work this out quickly. Okay, so A cross B will come out to be 0, but A cross C will not come out to be 0. Now see, why A cross B comes out to be 0 should have been pretty obvious. You don't even need to apply the matrix method. You can just observe over here that the vectors A and B are parallel. Because remember what was a parallel condition? Because Ax upon Bx is equal to Ay upon By is equal to Az upon Bz, which is in fact equal to 1 by 2. Or in other words, vector B is equal to 2 times vector B, which means that B is along A, but of magnitude 2. So if that is the case, that means theta is 0. So obviously A cross B is a null vector. Okay. But you can also check. You can also check by the matrix method. If you take A cross B by the matrix method, you will see you will get IJK 211422. So when you calculate this, each of the terms will come 0. Each of the terms here. So you will get 0 I cap minus 0 j cap plus 0 k cap. So that's a null vector. Okay, so this was unnecessary, but that's what you will get. Now similarly, when you are calculating A cross C, but this is not having that relationship. You can see that A is not parallel to C or anti-parallel or anything like that. So A cross C, you will get a non-zero vector. Two, one, one, 1, 2 minus 1. So let's calculate this now. So this will become minus 1 minus 2. So minus 3 I cap. Okay. Then minus 2 minus 1. So again minus 3. So this will become plus 3 with the minus sign outside. And this is 4 minus 1. So plus 3 K cap. So this will be my A cross C. Okay, good. So this is how we calculate the cross product by using the three-dimensional matrix method. See, this is minus j into, see, for the j cap part, you remove this column now. So you're left with these four terms. So 2, 1, 1 minus 1. Okay. So now this determinant, this one, it becomes how much? It becomes 2 into minus 1, minus of 1 into 1. So it becomes minus 3. And there's already minus sign outside, so that's how we get plus 3. Is it clear, Yojit? Okay, good. Okay, so this is how we calculate the cross product. So now, for example, in the same question, if I'd also asked you, find the area of a parallelogram formed by E and B. E and B. The answer to this would be 0. Okay, because A is parallel to B, so it can't form a parallelogram. But if I ask you the area of the parallelogram formed by A and C, so you can see that yes, A and C are not parallel to each other, so they are enclosing some kind of area. So A and C vectors are not parallel to each other. Yes, so 3 root 3 will be the correct answer. Okay. So this area will be mod of A cross C. So that is just mod of the vector that we had got. This vector. Minus 3 I cap plus 3 j cap plus 3 k cap. So इसका magnitude अभी कितना हो जाएगा? 3 root 3. Okay. So this will be this area. Now similarly, sometimes the question asked is the area of the triangle formed by A and B. So area of the triangle formed by A and C will be half of the area of the parallelogram. So if you look at the triangle, so you should also understand this. The area of triangle is half of area of parallelogram. So that is mod of A cross C divided by 2. Okay, so these are two standard kind of things that are asked about cross product. Understood, Nashikar? Okay, people. So hope this is clear. So with this, we complete the vector algebra portion. Okay. And we have done one more lecture in discussion of the module exercises, but that you can discuss with me over WhatsApp and try out the questions and whatever doubts you have. But please do it between today and tomorrow so that you are better prepared for the test on Sunday. And also next week we'll be starting Newton's laws of motion. So if anything is pending in vectors now, you will have to complete it and discuss the doubts directly with me, but not in lecture anymore. Yes, assignment 7 had cross product of vectors, Ritika. Assignment 7 has cross product of vectors, and there are a few more questions here and there in cross product of vectors. Okay, your module has few questions of cross products, and yeah, Shikhar, coplanar vectors are vectors which lie in a common plane. Okay. So just like we have the condition for parallel or perpendicular vectors, like that you have. So coplanar vectors. So for example, if vectors A, B and C are coplanar. Okay. So that means that vector C, for example, is in the same plane as A and B. Okay. So how to check? Okay. So now since A cross B is perpendicular to the plane of A and B. Okay. Therefore, if C is coplanar to A and B, then it it will imply that A cross B is perpendicular to C also. Okay. If C is lying in the same plane as A and B, okay, if it is coplanar to, then definitely A cross B will be perpendicular to this. Okay. So in other words, A cross B's dot product with C will become 0 as a scalar product. Dot product is a scalar, so we won't write it as null vector. Okay, Shikhar, is it clear? Yes, assignment 7 is the last of my assignments, and then of course there is module exercises 1, 2, 3, and 4. So if you also go through the recordings of the last couple of lectures, there are a lot of questions. Yeah. So if we just go through the last couple of lectures, there are a lot of questions from the module which are discussed in that. And that has applications of both the things that we learned today. The projections of vectors, the parallel and perpendicular projections, and the cross product. Okay. So you should remember these things. The condition for vectors to be perpendicular to each other, that dot product is 0. The condition for two vectors to be parallel to each other, that is ax upon bx is equal to ay upon by is equal to az upon bz. Okay, that's the easy way to check if they are parallel. And similarly, if three vectors are coplanar, then this is the condition, that the cross product of any two of them will be perpendicular to the third one. Okay, if the third vector is lying in the plane of A and B, if C is lying in the plane of A and B, then C will be perpendicular to the normal, and the normal or the perpendicular is nothing but A cross B. So C will be perpendicular to A cross B. Okay, so this is one additional concept to remember. Okay, people, so that's it for the session here. Okay, continue working on whatever is pending for you in vectors questions, and please keep sending me the doubts. I'll help you out with the solutions of those questions. Okay. Also, as I said, you will find a lot of the module questions worked out in the recordings of the last couple of lectures, so you can review them also. Okay, that's it. Thank you, people.